So in this video, we're going to look at solving quadratic equations in standard form when the c value is equal to 0. So once again, standard form, ax squared plus bx plus c, but in this case, c is going to be equal to 0. So this whole expression is going to go away. And then we're just left with expressions that have an x in it, one that has an x squared and one that just has x to the first power. X squared plus 6x equals 0. And actually, once you get the hang of these are easier than some of the other ones that we'll see. You might notice that there's a common factor, that each one of these has an x in it. So I can think of this as x times something equals 0. Now, in order to get x squared, I have x times x will give me x squared. And then in order to get the 6x, it's plus 6. So if I were to check this by distributing, x times x gives me x squared, x times 6 gives me 6x. And now that I see that I have two things times each other that equal 0, I can use the null factor law or the zero product property, whatever you choose to call it, and realize that one or both of these quantities should be 0. If one of these quantities is 0, then obviously the product will also be 0. So first I could say, well, either x is 0, in which case we'd have 0 times 0 plus 6, or just 0 times 6, which is 0. So that's going to be one of my answers. And then another answer would be, well, if this expression, x plus 6 equals 0, then when x is negative 6, what I'm going to have is negative 6 times negative 6 plus 6, which once again gives me my 0. So when I multiply them together, I get 0 as an answer. You don't have to check it like this every time, but I just wanted to give you an idea of what's going on. First, we can factor out our common term. That's where this x came from. Either this or this is equal to 0, because when I multiply two things together and get 0, one of those two things or both have to be equal to 0. And in this case, if x is 0 or if x is negative 6, then our product is going to be 0. This is a good example because there's a mistake that a lot of people make when they see a problem like this. They see, oh, each term has an x in it, so I can divide both sides by x. But of course, there's a problem with that, and I'll show you that after I show you the proper way to solve it. First thing that I like to do is to get all of the x terms on the same side. So I can rewrite this as 3x squared minus 10x equals 0. I subtracted 10x on both sides. Once again, my common term is an x, so I have x times 3x minus 10 equals 0. And once again, if you want to double check, x times 3x is 3x squared. X times a negative 10 is a negative 10x. So we know that that works. So either x is equal to 0 or the expression 3x minus 10 is equal to 0. In this case, 3x would be equal to 10 and x would equal 10 thirds. So it's a fraction. It's a little more complicated than our other examples, but that will also give me a 0 to my quadratic equation. Now, one thing that people do mistakenly is they'll divide both sides by x. And so this is a mistake. Don't copy this part down, but just to show you, they divide both sides by x, and then they end up getting 3x equals 10. And then they think the only answer is 10 thirds. But of course, when you divide it by x, that's not allowed if x is equal to 0. So we're kind of violating one of the laws of mathematics, and that's what makes one of the answers go away. And we're just left with x equals 10 thirds. So be careful here. Always set this equal to 0, then factor out what you have. Use the zero product property or the null factor law to find your two factors that are equal to 0, and then just solve for x. And here's one last example just to show some of the flexibility that you can have. We're not going to make the mistake of dividing by x, because we know if x is 0, then we're going to have a problem. Here I have 9x squared equals negative 12x. I'm going to add 12x to both sides. So I get 9x squared plus 12x equals 0. Now, at this point, you realize, oh, okay, I can factor out an x here and then just see what's left. But maybe you notice that 9 and 12 share a common factor as well. And the factor that they share is 3. So I could factor out a 3x, and then that's what's left inside would only be a 3x, because 3x times 3x is 9x squared. And what's left here is a 4, because 3x times 4 gives me 12x. I can play the same game, so 3x equals 0, x is equal to 0, or 3x plus 4 equals 0, 3x equals negative 4, x equals negative 4/3, and I can get both of my answers that way. Now, some of you might be thinking, well, I didn't really see that negative, or that 3 was shared there and that I could factor that out. What would happen if I didn't do it? And if we consider the same example, but we don't factor out that 3, watch what happens. I get x times 9x plus 12 equals 0. So this means that either x equals 0, same as this one, or 9x plus 12 equals 0. So 9x should equal negative 12. X should equal negative 12 ninths. See the connection? This reduces to this. And it's actually off by a factor of 3, right? If I multiplied this by 3 over 3, I would get negative 12 over 9. 3 was what I could have factored out there. So I can reduce this by 3 over 3, and I get negative 4/3 as my answer, which is the same as before. So it doesn't matter if you see that constant and factor it out, or you forget to. If you forget to do it, you just have to reduce your fraction at the end to get your most simplified answer.